there. But I would say the reason why they're importing all these engineers, we don't even have the workforce to support those style of advanced fabs. It's not a great strategic position for us to be in.
So we don't have the workforce for it?
To staff up an advanced semiconductor fab to the tune of TSMC style? No. I mean, the chairman / CEO of TSMC will say that very bluntly and has publicly.
Hi, and welcome to the Hard Tech Podcast. My name is Daniel Paul. I am your host. And sitting across from me today is a special guest, Brett Walker. I first met Brett in 2018 when I was just beginning to build my first startup, and he gave me some solid advice that was very helpful. So thanks for coming today, Brett.
Thanks for having me.
By the way, Brett is a very successful tech entrepreneur in Austin. And since this podcast is based in Austin, we're very, very happy to have him as a guest on this podcast. Can you go ahead and just generally introduce yourself and your background?
Yeah, sure. Brett Walker, CEO and co-founder of Electroninks Incorporated. My background actually is it's always been in hard tech, really. My undergrad was mechanical and aerospace engineering, and I got a PhD in materials. I got some IP based off of my PhD that I then spun off and started the startup company Electroninks Incorporated. Started it back a while ago now, right after I finished my PhD in 2013, and then out of the research park at the University of Illinois, which is where I got my PhD. I briefly did a postdoc at Harvard, came back to Illinois to start up the company because it's a whole lot cheaper to start up a company in Illinois than in Cambridge, Massachusetts, which might be the most expensive place to start a company I could think of. And then the company started growing pretty rapidly, had some good success. It was very difficult. I actually enjoyed living in Urbana-Champaign. I have nothing but good things to say about that experience. And great education there as well. And then hard to recruit tech people to the cornfields of Illinois, as it turns out. So moved down to Austin. I actually was I was born in Killeen, so I'm a native Texan. I was raised in Oklahoma, then educated sort of in Oklahoma State and then everywhere else.
You want to tell people how far Killeen is from Austin?
Oh, like an hour drive north. It's really not too bad. My dad was in the Army. And so I was born right outside Fort Hood, and then so only spent a couple of years there because my dad was retiring from the military at the time, and then like I said, grew up the rest of the time in Oklahoma. But so this was sort of, even though I hadn't lived prior to that in Austin prior. I had a lot of family in the nearby area, both in Oklahoma and in Texas, and it was the choice was when the company was growing was either move to Silicon Valley or probably move down to Austin area, which at the time had a Silicon Valley mindset, but a much cheaper cost of living. I don't know that statement is true anymore. Yeah. Cost of living has gotten significantly more expensive here over the course of the past decade. But however, company grew pretty rapidly here, got our Series A funding, then our Series B, and then now we have our headquarters really is in the Met Center, which is an industrial park right outside the airport off of 183-290. And so we have about 30,000 square feet there. And that's where our lab, R&D, and production is. But we also have larger toll scale manufacturing sites for our larger customers. So we have strategic relationships with certain investors, including toll manufacturing that's included. So it allows us to scale up much more rapidly in a much more agile fashion. As we've discovered, working with something as established and as stringent as the electronics industry, obviously supply chain audits are a big thing. And so working with sort of tier one strategic investors and partners to be able to scale up the business is much more advantageous than trying to reinvent the wheel as a startup, a small person startup. You have a lot of CapEx, you have a lot of expenses doing that, where otherwise now we piggyback off the resources that our strategic investors have, which allows us to scale up much more easily and ultimately allows us to focus on what we do best, which is really the fundamental materials, and allows people who that's their job is to scale up materials, allows them to do that far more effectively. So in general, I think the relationships that we have there work really well. So happy with that.
That's quite an intro, Brett.
Sorry, that was probably more than like a...
No, it's fantastic. It's exactly what I expected. And it shows my point initially about how important you are to the startup ecosystem here in Austin, especially from the hardware side of things, We hear a lot about software companies, but you're showing us that despite how hard materials could be, materials engineering, hardware engineering could be, it can be done from a startup standpoint. Can you talk about the intersection of material science and electrical engineering? And this is a funny concept for me because as a mechanical engineer myself, building my first startup, I ended up building basically an electronics product at the end of the day. And so what's the intersection? What's the intersection between materials and electrical engineering, and how do they complement each other?
Yeah, so I mean, there's a lot of intersection in our world. I mean, fundamentally we make metal deposition products. We make precursor materials for metal deposition. So they're high performance, particle free conductive inks that we use. That has a lot of applications in EMI shielding, interconnects, solar. Honestly, the list goes on and on, display, et cetera. But I mean, the fundamental intersection that there's if that was a Venn diagram, the two circles would be pretty close to overlapping as far as application space is concerned. Because so for modern electronics, for example, everybody has a smartphone. There really has not been, I would say, a ton of advancement in the laptop or the desktop space for the average consumer-based user. Yeah. Where most of the money is being spent, therefore, where most of the R&D is happening is in the mobile space, because that's the most pervasive form, I would say, of computing now. Is everybody's got a device on them at all points in time, myself included, or a few devices as the case may be. And so as you start shrinking down chipsets and having to have more and more computational power and more just consumer interaction and user interaction, there's a lot, all those boil down to significant electrical engineering design problems that then fundamentally have to be addressed by materials. So one of our primary markets, for example, is EMI shielding. So your smartphone now has more computational power than desktop computers had 10, 20 years ago. And as you start shrinking down chipsets, and now multiple chipsets, because now you don't have just processing units, you have graphics units, you have all sorts of other things, you have high performance RAM, you have all sorts of other just dense chipsets inside of a very small package, and including obviously wireless comms that go along with that are sort of the backbone of all of this. Well, EMI shielding is a big deal. As you start shrinking these things down, crosstalk between the chipsets can cause a lot of problems. Sure. And so the way they used to solve this is you'd stamp a steel or aluminum can and you just literally stamp a can, you'd put it over the chipset, and there's your EMI shielding. Yeah. Well, the problem with modern smartphones is you just don't have the real estate. You can't have giant metal boxes around your chipsets. You got to conformally coat these chipsets. So that's where our materials come in. So we provide conformal on-package EMI shielding, as well as not only on-package, as well as you can cover part of the board. We provide a number of different packaging EMI solutions there for back-end semiconductor packaging. And that's just our main application set. You can move on to display, which is another application set of ours. So as everyone knows, the big driver, I would say, for user interaction with the smartphone has always been increasing the size of the phone, but also eliminating the edges of the display. Everybody wants bezel-less display, right? Where there's no dark areas around the edges. You're just staring at a pure screen almost. Well, the electrode architecture for that is actually quite interesting because you have to be able to connect from the back side of the phone to the front side of the phone where the display interacts with the user in some ways. There's a lot of electrode architectures that go into that. So our materials play a fundamental role there as far as those electrode architectures. So it's all about material specs for me as a materials science, but those ultimately relate in a larger scale to electrical engineering design / device design on the designer front. And then we work with the OEMs or their contract manufacturers and then integrate those into packages that ultimately the consumer sees, or in DoD applications as well, things along those lines.
Cool. That's very good.
Again, maybe a more long-winded answer than you were looking for. But.
That's it. It's good. We love those answers. I mean, it's very explanatory. But I have a question about bevel edges for mobile phones.
Yeah.
Right? How challenging are those from as someone who is in the forefront of seeing that being created and working with the companies to do that?
It's a challenging application because you obviously have interdigitated individual electrodes that have to go around the front to the back of the screen. That's how those architectures are designed. And so those architectures in a traditional, let's just say in a traditional electronic technique, you may sputter down like just a blanket coating that's masked. So then you're actually removing like 90% of the metal at that point. It's a relatively inefficient use of the metal. Sputtering has to be done, or PVD has to be done in a vacuum environment. It's challenging. It doesn't do three-dimensional structures very well, so you're going to have sort of a multiple axes rotation thing set up inside of the chamber itself to actually place these materials. Okay. In general, it's a multi-step process and very challenging. With additive, which our materials come into play, we can match or beat PVD or sputtered materials as far as just materials performance is concerned. But then we can use alternative techniques like screen printing or aerosol jet printing to just put down the metal where it needs to go versus flood coating the metal over an entire edge of a bezel, for example, of a display, and then etching away most of it. That's a really cumbersome and wasteful process with a large waste stream associated with it. I'm not saying additive is waste-free. There's no such thing as waste-free manufacturing. It doesn't exist. Yeah. However, there are certainly far more efficient ways of doing things than vacuum-based deposition techniques for a lot of things you see. Vacuum is needed a lot on the front end of semiconductor just due to the sensitivity of the materials that are being used. But on the back end side / on the integration side, with a modern materials palette, I believe a lot of these vacuum techniques are reaching obsolescence just due to more need for sustainability in the manufacturing, as well as just less waste and less logistical headaches associated with production. Those are always going to be a growing concern, and vacuum-based techniques always have limitations associated with that.
Sounds good. Before we go any further, let's define some terms.
Sure.
Right?
That might be helpful.
Yeah. Just very briefly, just explain what sputtering and PVD stand
for. Sputtering is physical vapor deposition.
Okay.
So basically, you can take a metallic precursor, or basically just a metal that you then, in a vacuum-style technique, you deposit that down on a substrate.
Okay.
And then you either heat it or post-process it, or it's just heated in situ, and then you get a finalized film.
Okay.
That's always a blanket style technique. Same thing with sputtering, where you apply a charge and you have a target, and you're basically sputtering the metal down. And these are always vacuum style techniques, and you're laying down a blanket of the metal. So there's no real way to selectively deposit this. So you're just laying down a sheet of metal. So if you're trying to create a really complicated structure on a phone, for example, you have to have a photomask or you have to have some way to mask off the areas that you actually don't want to have the metal down on it. The metal goes down on it anyways, but then you're just etching it away at the end. So ultimately, you're spending a whole lot of money and a whole lot of time and a whole lot of calibration and validation just making sure you have the mask down properly, so you aren't just laying down a bunch of metal where you don't want it, so it gets removed when you want it to get it removed. And with additive, you're really only depositing the metal where it needs to go. You just have a nozzle or some other style system, or even just something as simple and as long-term been around like screen printing, where you're just laying down a metal where it wants to go, the only place you need it in the device, and you're eliminating a lot of post-processing steps. And like I said, the case with PVD sputtering is this is done in vacuum traditionally. So not only do you have post-processing associated with it, but the actual deposition technique itself is very intensive because the devices, or the portion of the device that's being put in the machine, has to be in a sealed atmosphere, which is really quite cumbersome when you start talking about large-scale production.
Okay, fantastic. Let's take a step back away from technologies and just talk about the startup ecosystem a little bit.
Sure.
Right? As someone who has built a company, a startup in Texas, in Austin, Texas, for a few years, if you had to define the most important events along the journey, it doesn't have to be, the kind of events that, that we typically hear of, like fundraising, or things like that, but like the journey of Electroninks, what would you say, like the very important things that happened along the way?
So, as it pertains to the Austin ecosystem, like to sort of put that as the bubble up top that we'll sort of focus around, I would say fundraising. Obviously, I would go fundraising and infrastructure is where my mind immediately goes. So fundraising, we raised our Series A shortly after moving into Austin, and BandGap, which is a small VC here in Austin that really focuses just on materials, which hats off to them. There's not a lot of VCs that focus on them. They're a small, focused fund, and a small VC group called BandGap. That was where we really coalesced our Series A around, was them, and then Applied Materials out of Sunnyvale, California, Santa Clara, Silicon Valley, California, the large semiconductor process equipment company that everybody's familiar with. They were our lead strategic, and BandGap was our lead VC. And then we've had follow-on investments in a number of other strategics, but I would say that was starting off a very important event. And then it's always been, being a materials company, infrastructure is not an option. That's one thing. You doing hardware, me doing materials, which is very chemistry centric. It's something that can never be understated. Is you have to have real infrastructure in place. It's where software you could work out of your garage or you work out of your house if you wanted to on your computer, et cetera. You can't. You cannot meet city codes and handle hazardous chemicals in your garage or in your house. So that doesn't work. So I will say that's been the most challenging aspect of the startup here. And I would just say a material startup in general is just infrastructure as we've grown. I call it the hermit crab in the shell model. Things that are appropriate for you when you first start off is, okay, we're sharing a lab / it's a shared facility. We have a few different tenants. We have access to a lab space. Then as we grew, we got more of our own lab space. And then eventually, after we got into our Series B, we finally moved into our own, what I call like actual headquarters down near the airport, like I said, at Met Center, which had a custom built out lab. But infrastructure is immensely expensive because of how specialized and how high tech it is. And it's just a very large investment that in a real estate environment like Austin, which is very software heavy, I would argue, a lot of landlords don't want to play ball when it comes to actually truly building out a space for hardware / hard tech. It's a very challenging conversation because there's always that risk factor with a startup, the amount of money. And then my counterpoint is, well, if you don't build it, like you can always look at the negative. Like if you don't build it, what's going to happen? Like these type of companies can't succeed here. This sort of ecosystem needs to exist, can't. And so luckily we did find a landlord who was willing to work with us and built out our facility. But ultimately, I would say, fundraising and infrastructure is the two narratives of that's always obviously fundraising for employee hires and runway, and then infrastructure is you've got to have a place to do it, and infrastructure is always a very challenging thing with materials. Chemistry infrastructure is expensive.
I know exactly what you're talking about. As someone who has built a hardware company myself, it's very challenging. Like pretty much maybe 80% of the buildings you go to, they're like, no, you're gonna be making battery related devices. Is it gonna leak into my building and things like that? So you know, we're worried about waste, we're worried about city codes and things like that. I fully understand. Well, let's move on. I'm gonna actually go further back to
further back. Okay, yeah, this will be interesting.
I'm gonna go a little bit, not that far. Like right after you finished your PhD, right?
Okay, sure.
You knew you were gonna launch a startup, right?
Okay, yeah.
Right. So what would you say was the catalyst for that? Was that spending some time in Boston or around the ecosystem there, or what?
I mean, honestly, I had already been involved in some very small, but like companies like in undergrad, et cetera, and even high school, like very small, but like just commercializing small things. And I always knew that there was enough commercial interest based off of my initial publication for my PhD dissertation that there was clearly a lot of pull for something innovative in this area. And so there was actually a couple licensing discussions that were already happening with what's called the OTM, the Office of Technology Management at UIUC. Okay. They're called OTDs, it's all the same thing. It's basically it's the office that oversees IP authoring associated with research done at the university, and then oversees licenses, et cetera. Okay. This one is called OTM. I believe Harvard, MIT is called the OTD. But I mean, it's all the same gist. It's all the same principle. And so early on, right after my publication had been released, there was 2 licensing discussions that occurred. And I realized, and those fell through for various different reasons that weren't related to that technology. It was just like business timelines, or one of the companies actually looking at doing a license actually got acquired during that process. So there was this whole, they got discombobulated during that whole process. So there was this whole lag there. And then I saw that there was enough customer pulling enough customer in. It's like, well, I have some experience here. So not with a material startup, but with doing some startups and commercializing things. I'm like, I'll do this. So, so the thought process was, after seeing that and seeing that there is real pull here, it makes sense to commercialize this technology. And who's more familiar with it than me? Because it is my IP. So yeah.
Okay, this is a very interesting story. I see why we had common ground in discussing in 2018, because something very similar happened to me coming out of my PhD program and deciding to develop technology that was basically similar to what I'd done in grad school. But I have a question for you.
Sure.
How, for anyone thinking about taking physical technology developed in school, whether it be hardware, materials, how would they know that technology is ready and know that this is not something that is too far off from commercialization?
That's tough to answer, and like my squirrely answer to that is that really is a case by case basis. But I mean, where my tipping point is just the amount of follow up from industry I received post the publication being published. There was a lot of follow up from a number of industry players. Like I said, there was a couple licensing discussions that were already occurring. That, like I said, those fell through for various reasons. But it was clear there's a lot of interest. So for you to already have commercially minded / companies reaching out to want to commercialize the technology, it shows that it clearly can't be super far off, right? Yeah. It shows that there are some potentially near-term applications. The thing with materials is, as everyone in the materials business knows, it just takes hardware in general. Materials is a very long timeline to market because there's a whole lot of qualifications you have to meet along the way, and each one of those has its own curveballs associated with it. None of it is a straightforward, linear, deterministic path. It is a slightly stochastic process. So there's just some level of unpredictability with that, and that's just intrinsic to startup world. But I felt like the pull of industry people really wanting to see this commercialized was justification enough to where I could see a pathway for funding, a pathway to move this forward, and a pathway to actually bring this to market.
Okay, fantastic. This is where I want to segue into talking about your technologies that you developed.
Sure.
Right? We've talked about your background, motivations, education, the process of building a startup. Now, Electroninks has developed some really good products. We'll start with particle-free conductive inks, right?
Sure.
And I was doing some research on this, and this is very interesting. Can you just explain what they are and how they're better than the typical conductive inks, right?
Sure. So the first thing is whenever like terms like printed electronics and other things are thrown around, people a lot of times think that's really recent, and DuPont would argue with you, and rightfully so, because printed electronics has been around since World War II.
Wow.
DuPont conductive inks were used for the submarine. The switches, the flat panel switches on the submarines to control submarines, that was DuPont conductive ink. And that's traditional conductive paste. What those are, and they've been around for longer than that even, is really it borrows from color ink technology, like literally printing press color, how they make color inks. What they do is you get a resin, you get some sort of solvent / a vehicle to carry everything. This resin disperses the functional filler. And so in printing presses, you just add in pigment, for example. Like I need my CMY, my cyan, magenta, yellow, and I can mix those. I can make the whole color spectrum, right? That's the way color theory works. Well, the philosophical thought process behind that I thought was fundamentally flawed when it comes to functional materials, because basically that's where conductive paste came from. It's like, printing press inks, have been around forever. They've been around for a very long time. The oldest ones are more or less glorified carbon black, because all ink used to basically just be black or various shades of black, just for making newspress on a paper, so you could just read something for contrast. But there was color inks, and then there was functional fillers. And Functional fillers are just like, oh, well, instead of us throwing a pigment in here, why don't we throw in silver flake, for example, or something else like this? And it's like, okay, if you throw the silver flake in there, you heat it up enough so the silver starts to coalesce, you'll start to get percolative conductive paths, and it'll become a conductive trace. And that is correct. That works. The issue that runs into a number of issues with various different deposition techniques. For screen printing, for example, that's fine. And that's where 95% of print electronics historically has been done, is screen printing. Because you just have this thick paste, you rub it on a screen, you use a squeegee, you push it across, and voila, you've got your design, whatever that design may be. Well, once you start moving into higher resolution printing techniques, like inkjet printing, for example, or aerosol jet printing, for example, you run into real problems with that. The real problem is inkjet, for example, needs really, really small particle size distributions to make a reliable ink. And it's like, okay, well, you can make silver nanoparticles. The issue is you've got to disperse them. Silver's dense, right? It's going to sink, and silver's got a density of 10.49 grams per cc. Water's 1. So like you start throwing that in there, it's just going to sink. So you got to throw dispersants around it. So all dispersants are is really just a polymer shell that's soluble in your solvent that has a certain charge to it to balance these things out so it stays suspended. Well, the problem with that is now in your cured film, you don't have silver. You've got silver plus a lot of polymeric gunk that ultimately doesn't help your film at all. So particle free is stepping it back and taking a page from semiconductor processing. Why don't we use precursor style chemistries that have an engineered decomposition to them so you know what those final films look like? And so it was designing a precursor complex that once we heat this up, this is just a completely soluble complex in a solvent. You heat it up and it just decomposes into pure silver. So what this does is you get much higher performance out of it. You also get much better environmental reliability. So instead of like, if you throw this in a humidity chamber and do all these customer tests that they've got to do, you have a high probability of failing with a lot of polymeric or organic gunk just floating around in there. Well, if it's a pure silver film, it's pure metal. It does much, much better at that point. So the entire idea was, okay, let's take the same semiconductor precursor design methodology, design philosophy, and let's apply this to modern functional materials with that. And then there's obviously a lot of materials chemistry and materials science that goes into designing these complexes and these decomposition reactions. But going from that side versus going just like, oh, we'll make a functional ink and instead of a pigment, we'll throw in some paste, we'll throw in some silver flake, for example. You just start off with the ends are going to end up with a much better result because you're designing what you want in the end. And what you want in the end is a pure metallic film. So you get a pure metallic film. So it just has a lot of performance advantages all the way around.
That's good. That's very good.
Again, probably a more long-winded answer than
no. That's a technical explanation. That's good. Now let's simplify it a little bit. I read that particle-free conductive ink is uncured, transparent, and smooth. Is that true?
It is. As you make it, it is transparent. As you heat it up, it turns into the bulk metal. So you actually have the silver ions or the metal ions in solution. Then as you heat it, it decomposes and forms a metallic sheet or a metallic pattern if you pattern it into a certain pattern. But it turns into the metal after a curing process. Okay,
fantastic. So just from a consumer point of view, like not the business that is adopting this technology from you, right? Not the the device manufacturer, right? Is anyone going to notice that their circuit, their board or whatever is using particle-free conductive inks? Is it? I guess the question I'm trying to get to here is it healthier? Is it safer for the environment? Does it have any benefits beyond the technical explanation you gave earlier?
It has a much better environmental footprint, but as far as what the customer sees of that footprint, that's debatable, honestly. So just going back to the manufacturing methodology, PVD uses literally hundreds of times more power than particle-free. So like these PVD, these sputtering techniques uses 100, 200, 300x power versus this, because these are vacuum chambers with high voltage supplies that have to do all this deposition work. we use spray coating equipment to do the same thing. So in ambient environment. So your power requirements are drastically less. Your water requirements are also about 40x, literally 40 times less. So your water usage is much less. So as far as the environmental responsibility and just overall footprint that a factory has, these materials have a much, much better footprint than you're going to see with traditional incumbent techniques. How much of that is visible to the customer on the interaction side? I would say it's relatively minimal, and that's a good thing. It's a seamless integration for the customer. All they know is that the device works like it always did. It's the same and continuing on a improving performance cycle for their end devices. But the actual environmental footprint of getting it there is much, much less.
Yeah, I want to just take this opportunity to mention that a lot of the work that we do, that many startups do, is not visible to the end user. But if your phone gets faster, it charges faster, the battery lasts longer. I don't know, it heats up less. That's the work of some small startup company, you know.
So, yeah, that's people do take for granted these incremental changes they see, and they just see like, oh, my phone's performance specs have improved. It's like, no, there was a lot of work that went into that. That the manufacturers see, and then the consumer sees an improved spec sheet. But as far as the direct connection to the consumer understanding what went into that, very little. But that's honestly it means the technology is being seamlessly transferred, which that's a good thing, I would say.
Yeah, exactly. Okay, this is a very interesting topic I want to get into. Circuit Scribe.
Yeah.
It's kind of hard for me to pronounce. Okay, so you developed this system or this technology, right, that helps kids become more involved in STEM and to learn about electronics and to draw circuits instantly. Is that a good explanation for Circuit Scribe?
Yeah, Circuit Scribe is an interesting topic. So to jump in there, so started the company in 2013, had some early grants around the industrial ink technology, the particle-free conductive inks, had some early grants, had some early customers in the additive manufacturing space and the wireless communication space, actually. Everything was locked up under NDA, like completely locked up. Could not discuss any of it. The issue was it was very difficult to market like what Electroninks was doing from an outward-facing standpoint because while we had really good, strong, early upfront customers and adoption, there was a long ways to go in the development cycle. There really was. That was very early days. And there was no way to really outwardly give people a feeling of what we were doing. And so Circuit Scribe was myself and other colleagues that I had both at UIUC that moved to Harvard and Lisa Rousseau, Michael Bell, developed this sort of this ecosystem. So it's a rollerball pen filled with non-toxic, water-based conductive ink, certified non-toxic, that dries immediately on paper, and it literally flows out of a rollerball pen. So as easily as you can draw with a rollerball pen, you can make a circuit. And so developed this sort of STEM education kit ecosystem, launched that on Kickstarter, holiday 2013, into the year 2013, launched that on Kickstarter. At the time, had a very successful Kickstarter campaign. I would say Kickstarter is very difficult to navigate nowadays. The signal-to-noise ratio is tough. That was back whenever Kickstarter was the new cool thing, which dates me a lot, I realize. But Kickstarter was like the big thing to launch a consumer product on at that point, like a consumer tech product. Had a very successful Kickstarter campaign, and then went into full production the next year. Was late, like every Kickstarter campaign, but actually fulfilled all of our customers and started global distribution of that product. And that became encapsulated as a wholly owned subsidiary called Electroninks Writables. So it eventually started as a spin-off to where that would just sort of encapsulated the Circuit Scribe brand, and that's very different from the focus of the industrial business of like integration to back-end manufacturing. The ink formulation is different as well. So that got encapsulated over the course of a few years. That turned into a wholly owned subsidiary, but still it's its own business unit. But yeah, it's focused on STEM education. And yeah, it's used globally. It's a really cool, interesting product and a really fun, creative way to get introduced to circuits. Where I feel like electronics is always taught in such a abstract way that it really doesn't have a lot of tangible, like I really see what this circuit is doing type of application. And the point of Circuit Scribe was to make it to where like as easy as you can scribble on a piece of paper, you're going to be able to actually sketch out a circuit diagram. And oh, by the way, that circuit diagram is actually a functioning circuit. If you plug in a battery, plug in an LED, which we have components for, etc., you can make a working circuit right there on a piece of paper. So it brings this level of abstraction very much into the tangible with a product that's non-toxic, safe, and easy to use.
That's fantastic. I'm gonna actually ask you about more about that in
Sure.
a sec. But you partly answered my next question. Kickstarter.
Yes.
Right? The heyday of Kickstarter was probably mid 2010s, something like that.
Yeah,
right?
20 teens, early to mid 20 teens. I would
Early to mid,
100%
okay.
agree.
Okay. So, yeah, I have two questions. First of all, if you had to give advice to someone who was starting a hardware company today or a materials company today that needed to go on Kickstarter to raise money for the first product, what would be?
The barrier to entry there is just a lot harder because a lot of people actually already have funding, like venture funding or like legitimate dollars behind them, and then launch their product on Kickstarter or do a pre-order or something along those lines on Kickstarter. I would say Kickstarter nowadays, it's a much harder game to play. And we sort of lucked out timing wise. A lot of startup timing is there's some luck associated with startup timing. There really is, and market adoption cycles and where you happen to fall when you start up and how far ahead of the curve or on the curve or behind the curve you are adoption wise with your technology. There's a whole just temporal aspect to that is very hard to predict and very difficult to get 100% right. And I will say with that is one thing we got frankly very lucky with was the Kickstarter timing aspect. Now, doing that now, I would hesitate to say I have a great answer because I think launching a product in that sort of way where the idea was to get customer buy-in early on, whenever Kickstarter started, it was a really interesting proposition. And now, like I said, it's honestly been infiltrated by a lot of people that already have a lot of money and then launch. And so to me, it kind of dilutes that experience a little bit as a result, where I feel like it's supposed to be about like just organic interest in developing that product versus pumping up with funding to begin with and then going into it. Not knocking that. It's a interesting way to sort of get metrics around customer adoption. But to me, the fundamental purpose of that platform was to be like, these are people that would not be able to raise funding elsewhere or otherwise. Let's give them a platform to really get out in front of people. So really the only cost you had up front, other than like having the baseline level of the product developed, was as with anything on the internet, a good video is what sells it. Your only cost is going to be having a video production company doing your video for you.
So the best thing is go raise some money, then use that money to go on Kickstarter to raise some more money.
Yeah, it depends on what you're doing. I think because of that's the way the Kickstarter path goes now. I don't know that Kickstarter is necessarily the best
way to go. Okay.
I would say back in its heyday, before it is what it is now. Back in its heyday, when it first started, it was really popular. I would say that Kickstarter is a great way to launch a consumer product.
Yeah.
I don't know. It's just so hard with. You go on there now, there's thousands of products, and all of them have extremely high-quality videos done. It's just the signal-to-noise ratio is hard to sift through now. There's no, like, just clear winners, in my opinion. It's a really tough game to play now. I don't know that I'd be able to navigate it. In fact, I can almost guarantee I would not be able to navigate it the same way today if put in the same position.
Plus, I've been spending some time on Kickstarter, on the Kickstarter website and Indiegogo website. And I started noticing that you can actually do way better on Indiegogo than Kickstarter now.
Yes.
Yeah, that's surprising. It used to be the opposite.
Well, yeah, Indiegogo was the Me Too, was the follow-on that had different terms of use and everything else. So they had their own little niche that they were focusing on. Because there was I forget what it was, but there were certain things that Kickstarter wouldn't allow that Indiegogo was more open towards, and as a result, they sort of served that clientele. I forget the exact terms of what they were, but no, I agree. Indiegogo has a lot more products on it.
Was it Kickstarter? If you set a goal, you must hit that goal to get your money. Whereas in Indiegogo, you don't really have to hit your goal. I'm not sure.
I don't remember the exact terms. I just remember there was a couple different differences that were substantial enough that that's what they marketed off of, and that's how they really started and got their own following as well. But Kickstarter was the original.
It was. I'm such a big proponent for hardware and physical technologies, and this is why this podcast exists actually. And I keep thinking about the different. You mentioned the word infrastructure, but let me use infrastructure in a more general way here. The infrastructure is needed for physical or hardware technology startups to thrive. has been eroded, basically. So, for example, it's hard to get a hardware company going. How about we have a Kickstarter company where you can just make an MVP and show off your MVP and get some funding? That's gone, right? You got to have a lot of money to be able to go there.
It's tough.
How about support? How about, when incubators and accelerators are picking companies, the entire language is just about, oh, have you written your code and things like that, right? And the entire ecosystem is being eroded. And you just mentioned a very good point. One of the ways in which you could circumvent that in the past was Kickstarter, and that's gone too. So that's very sad.
No, I agree. I think it's far more challenging because honestly, it's a testament to Kickstarter's success. Kickstarter was so successful at launching products that now people that are very well funded launch products there, and as a result, the sort of idea of getting access to something new and maybe a little raw that's unpolished has gone away because those products don't stick out anymore.
Yeah,
because a customer that's wanting to adopt something new is going to adopt the shiniest, most polished one, not the one that looks more raw, where previously I think you could get access to that a little bit more easily.
Yeah. There might still be a market, though.
I think there is.
Very, very early adopters who just want, okay, you have a solid idea about this thing. Let me take a look at it. Let me try it out. Because the reason I say this is a lot of companies, even established companies, will release products that are not perfect and tell you that we're still working on it. And everyone would just be happy. If everyone will be happy. They're acting like they start up with just an MVP, but under the cover of a really big company, like they're getting the benefits. It's really surprising. Anyway, let me go back to Circuit Scribe.
Sure.
Very important question here. Are you prouder of the impact that Circuit Scribe has made versus the impact that Electroninks has made as a company?
See, the thing is, I don't know that I would compare them because I both viewed them. They both have served their, and maybe this is far too calculated of an answer, and I apologize. I'm an objective-oriented person, but like they both have served their purposes very well. Ultimately, the fundamental, more disruptive technology is the particle-free inks and the development and those materials and what they can do for manufacturing electronics, consumer and otherwise. However, I don't think it can be underestimated the STEM educational impact, as well as just the general public awareness that Circuit Scribe offers to an otherwise esoteric industry. Like if I talk to somebody about really in-depth hardware / material integration problems inside a device, 99% of the population is not going to have a clue what I'm talking about. I can talk to anybody in the general population about Circuit Scribe, show it to them, they know what it is. So the thing is like I just view them as having different goals and different paths, and them both achieving their goals in various different ways. It's not prouder or less proud of one or the other. It's they're very different things with very different purposes. That's how I view that. So that's my perspective on them.
Okay, fantastic. So one more question: are you able to see both sides of the consumer in terms of the device manufacturer, let's say that's one of your customers, and let's call the students, STEM education also,
sure.
Like the end user versus the device manufacturer? You're able to see both sides and see which one seems, let's just say, more fun to work with.
It's just, and again, that just depends. I have had some of the most fun technical challenges that I've just professionally had enjoyment working on, dealing with the device manufacturers who day in, day out have to solve really hard problems.
Easier. It's a lot more. Go on, sorry.
So they have like very real problems. And the thing is like the level of your solution just has to be at such a higher level because they're not talking about, I need this to work once. This has to survive unbelievable reliability tests and show that it's going to last out in the wild, however you want to call it, for 10 to 20 years and not have problems. And developing solutions around that actually turns out to be those nuances on how you tweak the solution there start to become very challenging, and you really sink your teeth into that. So I get a lot of enjoyment there on the technical side. However, it's also really enjoyable to see students who may not otherwise be involved or interested in STEM get engaged in that field because now there's a tool available That doesn't make it like this far off, I'm not good at that, or I don't know how to do that topic. It's something that now it's very accessible. And if you're going to access a student that way, to me, if you access a student on their passions versus their competencies, you're going to find a lot more people have competencies in areas that they didn't know that they had. Sure. Where if you engage them immediately off their competencies versus their passions, you end up with a more disengaged student and or workforce later on. So I feel like it gives the opportunity to have a more passionate, competent professional versus sheerly competency.
Okay, fantastic. Okay, let's talk about one more product, circuit jet.
Sure. Yeah.
So on this channel and on this podcast, I actually make videos where I talk about emerging and new physical technologies or hardware technologies.
Yep.
And one of those videos that we just uploaded it talks about 3D printed food, right?
Okay. Yeah.
3D printed food, right? Yep. So we're seeing that you have something called circuit jet that prints a circuit board from a printer. It's got me thinking, where are we going with this? People used to hate printers. Now printers are printing food. You're printing circuit boards. What's next? Are we going to start printing robots from printers? You
never know. But yes.
But talk about circuit jet real quick.
So circuit jet really is sort of a bridging the gap of a more professional solution. So it's like, okay, you learn. So over here, we've got industrial materials, which is hardcore integrated into like very advanced, complicated manufacturing lines. On the complete opposite end of the spectrum, you have a rollerball pin filled with conductive ink to teach kids like what basic circuit concepts are of electricity, magnetism, etc. Well, so circuit jet really started on a way, as soon as you start learning how to make basic circuits, they start getting so complicated very quickly that you aren't going to want to write them by hand. It's not very practical. Even hooking up an Arduino, some relatively simple microcontroller, there's too many interconnects for you to do it by hand. You immediately have to use towards a more automated deposition device, i.e. a printer. Like you've got to have something along those lines. So where circuit jet really started was the idea of having a desktop tool that allowed you to create PCB prototypes rapidly with conductive inks. There was a lot of post-COVID when the DoD really started focusing on our supply chain is really weak, as far as most of our electronic supply chain is not a secret, runs through China/Asia Pacific. That they view that as a strategic weakness because for the past 30 years, we basically outsourced the entire electronics manufacturing industry overseas, which is a big problem from our just strategically and our just domestic workforce and manufacturing and labor. That's why a lot of the infrastructure, I would say, doesn't exist over here, is because none of the manufacturing is happening over here anymore. And so there was a lot of interest there. And so we got some DoD-based contracts around that. And then that's really morphed into legitimate PCB prototyping, where it started off with just conductive inks. And we have that more as a more professional educational tool for people that are more advanced electrical engineering courses to do PCB layout. Now Circuit Jet has the starting substrate for our more professional units are copper-clad laminates, like actual PCB substrates. You use a laser etcher to etch it away, and then you actually use inkjet to come in to use our materials to fill in vias, to finish the board in gold if you need an ENIG finish, like a professionally finished board, print down solder mask, dispense solder, pick and place components so that you can literally have a full PCB fab in a box. That's what it sort of morphed into because we saw a lot of customer demand there and I've had pull towards that way. But it started off as we needed a more professional tool that's more a simple printer style thing to now where there's actually a lot of demand is we can't create all the plating infrastructure that they have in China or other Asia Pacific regions here. But what if we could sidestep that entire need for all that environmentally heavy footprint style of manufacturing and actually just have a more learn those lessons that we've learned from outsourcing for the past 30 years, consolidate that down, use advanced materials to sidestep some of those issues. Okay. And now you can have PCB prototyping in something the size of a microwave. That's not too bad.
That's good. That's a good visual right there. The size of a microwave. You could print out PCBs. Okay. Yeah. It's a very good discussion right now because we can get into the next question, which is, do you think it's important to bring back advanced manufacturing to the U.S.?
I absolutely think it's important to bring back advanced manufacturing. I think we've got a long way to go there, just because we have outsourced this for a very, very long time.
30 years.
To our detriment.
Yeah.
And as a result, the emphasis on the workforce isn't there. As TSMC has very publicly said, TSMC, they're building giant plants here now because of the CHIPS Act and everything else. they are importing a lot of their engineers and workforce from Taiwan over here. That ultimately, I don't view that as a bad thing because they'll assimilate over here and we'll have access to a much better workforce with immigration, et cetera, even though immigration in the U.S. is a whole different thing that I really don't want to get into in the podcast. But regardless, like even though it's a convoluted process, at least there would be a pathway there. But I would say the reason why they're importing all these engineers is that we don't even have the workforce to support those style of advanced fabs. It's not a great strategic position for us to be in.
So we don't have the workforce for it?
To staff up an advanced semiconductor fab to the tune of TSMC style? No. I mean, the chairman / CEO of TSMC will say that very bluntly and has publicly.
Wow. I see why we have problems actually launching startups in that space too, because we don't even have people interested in it in the first place.
Well, also the problem is there's a lot of interesting new technologies being developed in R&D. The problem is the cost of entry. Like we've had discussions with we have strategic investors that are all over the semiconductor packaging side. So let's say you come up with a technology that really may increase the productivity or any sort of efficiency in the semiconductor realm. Testing it out is a hundreds of millions of dollar problem. True. You can't just like plop something into a semiconductor fab and see if it works. That's not how those things work. Yeah. So when you come up with processes, unless you have an infrastructure around feeding those systems, like all the auxiliary factories, all the auxiliary support that goes into feeding these larger semiconductor fabs, you'll see that there's just these larger and larger chasms start getting excavated around breakthroughs because there's no one in those intermediate steps supporting that. Because so back in its heyday when Intel built its new Pentium processor plant, in outside of Phoenix, Arizona, that's still there.
Is it in Chandler?
Yeah, it's in Chandler, Arizona. That's correct. And so it's not just the factory that's there. It's like, yeah, that's great. Intel built a plant there. It's a huge plant. It was a great feat. It was the whole thing is very advanced. It's the 1,000 other factories that go around it that feed that plant. Because a semiconductor plant does not run on its own. True. It's fed by a bazillion other industries, a bazillion other material and part suppliers that feed very specific parts that are very high precision and go through a very qualified supply chain. So when you start outsourcing the manufacturing or we don't invest in new next-gen fabs here, what the public immediately sees like, oh man, there's a $4 billion Intel plant. That was how much it cost, I believe, whenever they built that one in Chandler. It was $4 billion back then, by the way, not now.
How long ago was that?
It's been 20 years, I want to say.
Wow.
15, 20 years. And so what the public doesn't see is like, it's not that plant. That's a very important thing. That's sort of the capstone. It's all the other suppliers that have to feed that plant. Yeah. And whenever that infrastructure gets eroded, / that supply chain gets eroded, what we don't see is all the support that goes into making that. So there's a whole lot of very skilled labor that goes into that. People that will choose career paths as a result of a secure job that comes out of college doing those things, et cetera. And that whole thing just sort of evaporates. And so you don't have an ecosystem to feed this very, very large machine that is an advanced fab.
Wow. The problem is very fundamental. It's very grassroots.
It's very grassroots. It's like we have to value we have to value making things versus saving a couple pennies short term. It's the argument I always have with my friends is like we've been playing quarter by quarter capitalism, and our competitors have been playing decade by decade to century by century capitalism, and it's not serving a larger purpose for us. Yeah. I'll put it that way. It's all about quarterly revenues versus what's our long-term growth and goal strategy, and we've kind of betrayed our future selves because we want to make next quarter selves look a whole lot better.
Wow. I never thought about it from a grassroots standpoint. I mean, but then it's true. It's very true. Okay. Let's move on to artificial intelligence.
Okay.
Right. AI, ChatGPT, everything is just about that right now.
Yeah, it is.
How do you think? So I was reading an article in Forbes a few days ago that says something about AI innovation in manufacturing can be manageable and incremental, involving employees in the process rather than being overwhelming. That's a funny way of saying there should be a way to still keep employees while integrating AI into manufacturing. What do you think? What do you think is going to happen in the next few years with AI and manufacturing?
I do think it's going to be more of a gradual process. So I think I do, because don't get me wrong, there's a lot of automation. There's a lot of gaps that can be filled by AI that's going to more automate this process, where I would say a lot of our processes are stepwise automated already, especially in like semiconductor fab, other things like that. But there's obviously key personnel in between there. I believe some of those positions will start to phase out, but I think that will take time to do that. I think the consumer-facing portion of AI, and I could be completely wrong on this, is going to grow much more rapidly. So like the ChatGPTs of the world, right? It's a linguistic model. You ask it an actual scientific question, it gets it about 50% right. Literally about 50% right. About the last half of it's a mess. I've asked it, I've been curious about this, so I've got a ChatGPT account, I've gone in there, and I've started asking it like just basic chemistry protocol questions, like how do I perform this reaction? How do I perform this reaction? It gets about halfway through and totally messes up the last half. Not saying that it won't totally mess up the last half in like 5 years. It might get it completely right in the next couple of years. I'm just saying like these linguistic AI models are one thing, and I think it will change the way we interact with seeking out information, with a much more intelligent understanding of how to gather the information, like sort of the next version of Google, basically. I do believe it'll be disruptive to how we consume information.
Okay.
I do think there's still some fundamental gaps, though, I think, on the actual technical side that I'm not saying AI won't be able to resolve. But everything I've interacted with that's AI/machine learning, whatever buzzword you want to use, on that front still has a lot of fundamental gaps, just because our models, when it comes down to advanced chemistry, we have a lot of computational models that still aren't fundamentally like 100% correct, right? They're really good approximations, they're really good theories. So what is the AI going to run off of? That. It's not, we don't have perfect physical models for things that are absolutely 100% infallible by any means. I 100% believe AI is going to continue to be disruptive and continue to grow and be a growing portion of that segment. From what I've seen on the fundamental hard sciences side, there's some gaps. Where I see it being far more disruptive far earlier on is how we consume information, though. I do see a very big disruption there.
Okay, fantastic. So we're coming to the end of this podcast right now. Can you go ahead and just tell everyone how they can find you, support your mission and what you're working on and everything?
Yeah, sure. You can find me on, you can just email me. My email is just Brett with 2 T's, because that's the only way to spell it. But anyways, Brett at electroninks.com. That's honestly the best way to get a hold of me. I don't have social media. I refuse. I don't have it.
Why?
Our company has social media. We don't have time in the podcast to get into social media. Yeah. But I have LinkedIn, because there's professional benefits to having LinkedIn, and I've actually made a lot of meaningful connections off of LinkedIn. Social media is, I won't get into it, but I don't view it as a beneficial interaction. Therefore, I'm not on it. Okay. Business-wise, it makes sense. Personally, I personally don't see the benefit. Therefore, I don't participate. Because I don't like being the product, is the blunt answer.
And if people want to see what Electroninks is working on or what you guys have built, they go to Electroninks.
Electroninks.com will do the job.
.com, yeah. And I think Electroninks.com, CircuitScribe.com?
CircuitScribe.com too.
Yeah. Those are very good sites to go to see the work that has been done by a wonderful Austin-based material science hardware company in the PCB space, electronics space, and I think a lot can be learned from what we've discussed today about the success of a company within a space that it doesn't have the infrastructure that other spaces have for it to succeed properly, and you still manage to do really, really well. So thanks, Brett, for coming today. This was a really, really good discussion. I'm happy to have you here.
Yeah, thanks for inviting me out. It's good to see you again.
Yeah. And with that, we've come to the end of another episode of the Hard Tech Podcast. Thank you for listening. If you enjoyed this episode, please like and share this video. Also subscribe to the channel and hit that notification bell so that you see more videos like this.